All right, thanks for coming on in today. Having a little bit of a technical difficulty. A piece of software that I normally use to show you the mathematics isn't working, so I'm having to find one on the fly here. And I think we can make this work if I just do this. Give me 1 second. And I should be able to, oops. Oh, it won't do that. So what if we do, here we go. And if I just make things bigger, the website that I usually use for doing all the LaTeX, which is typesetting software, is down at the moment. Oh, is it up now? Oh, they just came back. Okay, it's been down for about the last 10 minutes. It looks like it's back up, so I can actually use the normal thing then. I don't need this. Great. Okay, good. That was going to be irritating. Okay, good. So it looks like we're back. The website's been down. I've been trying to get it up, but it was sometimes that happens. Website goes down, database doesn't work right, or we won't even go into what the error message was. But anyways, it's working again. So what we're looking at today is sort of finishing up our factoring. And as I've mentioned, this factoring is one of the most important topics from the course. The truth is, in your future math classes, your teachers will largely decide how well you can do stuff by your level of factoring. I mean, that's a thing that comes up frequently is, other teachers, sometimes they try to move students around. If a student's not ready for Math 4, college algebra, pre-calc or something, they're like, well, this is a common thing you hear. Well, this student doesn't know how to factor, because it's hard to move forward in your mathematics if you cannot factor. So it's pretty important, especially if you're going into something that's more science, engineering, something that actually uses mathematics. The factoring is going to come up. If you're eventually going to take a stats class, not quite as important. You don't do a ton of factoring in there, but it's definitely one of the main benchmarks that people use to figure out, is this person good at math, or is this person struggle with math? If you can factor, then they're like, okay, this person can probably move ahead. So it's important, and it comes up a lot. We will use factoring next time to solve equations, but that's not the only thing that we use factoring for. Oh, did I meet? Okay, yeah. We use factoring for lots of things. So we will use factoring at the end of this chapter to solve equations. Very important in mathematics to solve equations. We will use factoring in the next chapter, the last topic of the course, for a completely different reason. And as you work through algebra, it's just factoring doesn't go away. It just comes up again and again. And sometimes, it's actually kind of interesting. Students will say, I already learned this. I learned this before. And then you go, okay, do you know how to do it? No, but I learned this like before. Why are we doing this again? And there's a couple reasons. One, if you don't know how to do it, then you didn't really learn it before. But also, there are topics that keep coming up in mathematics. It's not like a checklist that you can just say, well, I looked at this once, and so I don't have to do it anymore. It's these tools all work together. Like graphing lines, finding equations of lines, those come up in every math class, from statistics to calculus to all that kind of stuff. Graphing lines. You go, I graphed lines in beginning algebra. Right, and you'll be doing it again in calculus. It's a thing that comes up fairly frequently. Factoring's another one of those topics. I would say those are the two big ones that just never go away. Factoring and graphing and solving lines, those are just used all over the place. spider behind me on the wall, apparently. You can't see that if you're on the YouTube, but you can see on the YouTube stream, but you can see it in Zoom. Anyways, it's gone now. Sorry, just distracted me. So we're going to finish up factoring, and then we'll actually see why we went through all this trouble of factoring. Okay, so the first thing we want to get through today is what's called special forms. It's 3 special cases of factoring that come up, yes, kind of regularly. Difference of squares comes up. The other ones don't come up as much. But they're just some formulas that you're expected to know how to apply to factoring. So we'll look at those. And then we want to come up with an overall factoring strategy. And we'll talk about that in a little bit here. So you'll have some homework that you're looking at where you have to use 3 different formulas. Okay, technically there's 5 formulas that are given in a section like this, but you really only need 3 of them because 2 of them you already know how to do. So I never saw the point of teaching students 2 new formulas for something that they already know how to do and don't need a formula for. What's the point of that? So you can learn the perfect square factoring of perfect, what do they call it? Perfect square trinomials is what it's called. Factoring perfect square trinomials. If you want to look up those formulas and learn them, go ahead. But I've never seen the point because you don't need a formula to factor those. They are trinomials. You already learned how to factor trinomials. Why are we learning a special formula for a very few select trinomials that, by the way, you already know how to factor? So feel free to look up those perfect square trinomials formulas if you like, and if you want to learn them, go for it. I never found them to be all that helpful. But there are 3 that you need to know because without these 3 formulas, you won't be factoring this particular type of problem. That is difference of squares, difference of cubes, and sum of squares. So 3 formulas, okay? And they are named what they are. So when we say a difference of squares, it's literally a difference of squares. So remember, a square is something that you get by multiplying something by itself. So like, you know, if you had a square, like you drew a square and the sides were 3, so it's a 3 by 3 square. What's the area? 9. 9's a perfect square. 16's a perfect square. It comes from a 4 by 4 triangle. 25's a perfect square. It comes from a 5 by, sorry, I just said triangle, square. 16, the area of a square that is 4 by 4 is 16. So 16 is a perfect square. If you have a square that is 5 by 5, the area is 25. 25 is a perfect square. So that's what we mean when we say a perfect square. So if we have, say, x squared minus 9 is a perfect square, or it's a difference of squares because it's a difference, which just is a different word that we use for subtraction. X squared is a perfect square because it's x times x. 9 is a perfect square because it's 3 times 3. X squared minus 9 is what we call a difference of squares. The 2 terms there are squares. The subtraction is a difference. It's a difference of squares. Okay, so we're going to learn how to factor things like this. Most of you will get this immediately or pretty quickly. You'll figure out what we're talking about in this situation because it's an easy formula. Students learn it very quickly, and then they apply it. Then we'll get into the difference in sum of cubes, which is a little more complicated. It can be intimidating at first, but I'm going to show you how to remember those formulas, and then we'll see, hopefully we'll have time to get to the factoring strategy later, and we'll go through that. But we want to sort of wrap our brains around this first. So let's say the truth is you work backwards for these formulas. Like you might look at these formulas and you're like, where did those come from? It's just working backwards. So, but you don't need to like derive them. You just need to know how to know the formulas and then use them. So let's say we have something like x minus y times x plus y. This is actually a pattern in mathematics that we use frequently to our advantage. It's where you take 2 things and you take the difference and the sum and you multiply those together. And at first you go, why is that a pattern? Why is that a thing that's useful in mathematics? Why would I have 2 objects, I'm going to take the difference And then I'm going to take the sum and multiply those together. What is that supposed to give me? And the answer is that it creates a very convenient way of eliminating certain types of terms. You're going to see some canceling occur in this problem. And we actually use that to our advantage later in the course. We won't get to it in here, but next semester when you're in the Math 3 class, when you're taking intermediate algebra, you'll see when we rationalize denominators, when we divide complex numbers. There's a number of different things that when we take this pattern of the sum and the difference of two things and multiply them together, we get some really nice canceling, and that's beneficial to us. At the moment, you're just going to see it in terms of this one problem that we're doing, but just be aware, like, oh, that's a useful pattern, so that when it comes up again down the road, you can go, oh, that's kind of like in difference of squares where their middle terms cancel out and it's really convenient. Yeah, that's why we use it. Okay. So let's take this and multiply it out. And you might go, how did you come up with that? It's because someone figured out that it works. And so then we use it, right? So if I multiply this out, I get x squared plus xy minus xy minus y squared. Right, so all I did here was FOIL. All right, it's going to make me, it won't let me, it's going to make me keep pushing the button every time. That's weird. I think they're still having some server issues, it looks like, so it's not letting me do auto compile automatically. Anyways, here's how I FOIL, right? First, outer, inner, last. Well, look at our outer and our inner. Look at those two terms. It looks to me like they cancel, and you're just left with x squared minus y squared, which is our difference of squares. So yeah, the website's still having some difficulties getting started up, so we'll have to stick with it, but at least I can kind of use it. So x minus y times x plus y simplifies to x squared minus y squared. In other words, we can use that formula backwards to say, well, then if I want to factor x squared minus y squared, it should factor as x minus y, x plus y, right? Yeah, you can take an equation and just write the left side on the right, and now you have a formula that works the other direction for you. That's totally reasonable. We do that all the time in mathematics. So this is giving you how you factor x squared minus y squared. Now, students try to skip steps by not writing stuff down, and I try to encourage them to write it down, and people don't believe me. This is one of those instances. I see it all the time when we're doing this in the classroom. The students who write, like they take my advice and write down what I tell them to write down, they finish the problem sooner. Okay, there are students that are like, oh, I can just do it in my head, and yet it's taking them 3 times as long because they're getting confused in their head. Now, yes, some of you will get to the point with the difference of squares where you can factor these so fast, you don't need to write down the formula, especially for difference of squares. But I will tell you, I see people struggle with difference of cubes and sum of cubes, which we're going to get to in a few minutes, and then they don't write the formula, and then they either get part of it wrong on the test, or it takes them a lot longer to do. So just trust me, just write the formula. The formula is your roadmap through the problem. Why would you ignore it? You go, well, I'm not ignoring it. I'm thinking about it. And you're not thinking about it very well then, because most people can't, until you're really good at these, you can't think about the problem that you're doing, how you're supposed to do it, and the formula, and write down the correct answer all at the same time. That's like 4 things you're trying to do in your head at once. That's a good way to make a mistake. Now, once you've done, if you're going to end up taking calculus and you've done a couple hundred of these, yes, then you may be able to do some of these problems in your head, even the difference of cubes ones. But it's unlikely. I see a lot of students, even that are comfortable with it, make mistakes because trying to do too much in their head. Okay, so what I recommend, especially when you're first learning the topic and you're just getting used to it, write down the formula and use that as your roadmap through the problem. So what does that mean when I say that? Well, let's go back up here and let's just model the part of our equation that applies to this. Well, we're looking at x squared minus y squared equals, well, the other part of our formula is x plus y, x minus y. Okay, so see, here's our formula. It's going to guide us through the problem so I can see, okay, over here I'm going to have an equals. I need an equals up here. Okay, let me put that in, equals. And then I'm going to need some parentheses, and I'm going to have a sum and a difference in there. Okay, and what are the x and y? Where do those come from? Well, they come from what you square to get the pieces in your problem, right? X is what you square to get x squared. Y is what you square to get y squared. So I need to figure out, what do I square to get x squared? Well, it's x. So it's going to be x plus x minus. And then what do I square to get 9? And the answer, of course, is 3. I square 3 to get 9, so now I'm going to stick the 3's in here. So I get 3 and 3. X plus 3, x minus 3. So x squared minus 9 equals x plus 3, x minus 3. Okay? See what I'm saying there? So that's how you factor that. And if you multiply this back out, you'll get x squared minus 9. So this one's a lot more straightforward than the ones we're going to look at in a couple of minutes here. Let's do a more advanced one. Let's say we've got 25x squared minus 36 y squared. Excuse me. So I have to factor this. Okay, I'm going to factor this problem. Where did it go? See, the website's not working quite right. Okay. So why don't I write my roadmap in there, my formula to show me through the problem. And some of you that are like, yeah, I get difference of squares. Trust me, you're going to want to write the formula when we get to the cubes problems. Okay. So, all right. Well, what do I square to get 25x squared? Well, that would be 5x times 5x, right? Okay, so I'm going to have 5x plus and 5x minus. And then what do I square? Oops. Right, so here's our roadmap. Here's our actual problem. What do I square to get 36y squared? Oh, that's going to be 6y. So now we're going to put our 6y's in here. And then we recompile. And we have our factoring. So let's see this in action. So here we have difference of squares. We want to factor it completely, right? So you might not know your squares yet, but you'll learn them pretty quick because they come up regularly in these problems. You're going to see 25. You're going to see 9. You're going to see 16 and 81 and 100. And all these numbers are going to keep coming up because they're perfect squares. So there's certain problems you're going to see are perfect squares. Certain problems you're going to see aren't. So how do we do this kind of a problem? Well, let's think about that formula. We've got two sets of parentheses. Okay, what do I square to get 25x squared? That's going to be 5x and 5x. We just did a problem like that. And we're going to have a minus and a plus in here. Now, what do I square to get 81y to the fourth? Well, let's see. The square root of 81 is 9, so it's going to be 9 something. Let's put our 9's in there. What do I square to get y to the fourth? Well, that's y squared times y squared. So it looks like this will be y squared. Y squared. Oh, actually, oh, yep. Okay, I thought for a second maybe it wasn't fully simplified, but it should be. So I hit yes, and it likes it. So you can see they did the same thing I did. They don't even show as much work as we did when we were writing it out, but they're like, yep, it's just difference of squares. Apply those squares in here, and then you get your answer, right? So most people do pretty well with the difference of squares. They move along pretty quickly with that one. Where it gets a little bit more complicated is in cubes. So notice that I didn't talk about a sum of squares formula. There is no sum of squares formula. So be careful, because I sometimes see students try to factor things like the following: 25x squared plus 36y squared. And then they try to force it to be a difference of squares, but this is not a difference of squares, is it? This is a sum of squares. We do not have a formula for this, mainly because you don't get this nice factoring that occurs from the inner and the outer terms. It doesn't occur in this kind of situation. So in fact, this right here cannot be factored. This is not factorable, okay? So just be careful. Difference of squares is called that for a reason. Now with cubes, it's different. We do have a difference of cubes formula and a sum of cubes formula. We do have both. So you have 3 formulas total. You only have 1 for squares, but you have 2 for cubes. So the formulas are not super easy to memorize, but I'll give you some hints, and then students get them pretty quick, right? As long as you're not being lazy about it, students tend to get these. So let me show you what these would be. This is going to be x cubed minus y cubed equals x minus y times x squared plus xy plus y squared. Okay, so x, let me see, let's move this over so you can see it a little better. Okay, so here's your formula for a difference of cubes. When you run across something that's a cube and it's a difference, you're going to use this formula. Now, some of you aren't that comfortable with squares. Your cubes you're even less comfortable with. The good news is there's not a ton of cubes that are going to come up, because cubes get big really fast. So we're not going to give you, there's just not that many. You're going to see the same numbers coming up again and again, right? 1 is 1 cubed. 8 is 2 cubed. 27 is 3 cubed. 64 is 4 cubed. See how big these numbers are getting really quick? By the time you get to 10 cubed, you're looking at, what, 1,000? So we don't, you're not going to see that many problems where you have to recognize what 9 cubed is equal to. I don't even know off the top of my head what 9 cubed is equal to, whatever 81 times 9 is, right? So my point is, there's not that many new numbers that you have to learn and recognize when it's a square or when it's a cube. There are some numbers that are both. 64 is 8 squared. It's also 4 cubed. So you have to pay attention to that. But here's our formula. Here's our roadmap for 1. And then let's take a look at the sum of cubes formula, because it's very similar. This is going to be x squared minus xy plus y squared. Now, you may look at these two and go, oh man, those are like a lot to remember. But here's the good news. You can kind of recognize there's some structure here. You might use the wrong one at the wrong time, but I'm going to give you some clues so you can learn these formulas and then you won't. So first of all, do you see the pattern's the same? It goes x cubed, y cubed, x, y, x squared, xy, y squared. It's the same overall structure in both of them. What's the only difference between these two formulas? It's the signs, right? If you look, the signs are sometimes different, but not the actual terms. Now you'll start with a problem that is one of the things on the left. So all you have to do is remember the part on the y and go, well, it goes x, y, x squared, xy, y squared. And then you have to figure out what to do with the signs, but we have a rule to help you with that, okay? So the rule is, it's called SOAP, which stands for same, opposite, always positive. Okay, same, opposite, always positive. So remember, you're going to be dealing with something, you're going to be given something on the left. So you're already going to know what the thing on the left looks like. Okay, so how do you figure out the signs that come after it? Well, the next sign is the same. That's the S part. The next sign is the same. So from minus to minus. The O stands for opposite. So the next one is the opposite, so from minus to plus. And then AP stands for always positive. That means our last one here is always a plus. Okay, and notice it holds for this one as well. So let's say you were given a problem like this. Okay, the next sign is the same. Okay, good. The next sign is the opposite. Okay, and the last sign is always positive. Oh, okay. Right, so that's how you can remember the signs in there. It's just SOAP. Same, opposite, always positive. And you go from there. So let's, for instance, let's do a problem. Say I'm looking at 8x cubed minus 27y cubed. Okay, that is a difference of cubes. I can tell because these are both cubes and there's a difference. So it's a difference of cubes. So I'm gonna grab the sum, the difference of cubes formula. Now, as far as learning these formulas, how should you go about doing that? I recommend that every time you use one of these formulas in a problem, you write it down. There's two reasons for that. One, I write it down in the problem because it's my roadmap through the problem. So it's like it's my guide work right here that's going to guide me through the problem. The other thing is that each time you write down these formulas, you're learning it a little bit better. So many of you, by the time you just finish your homework, if every time you use one of these, you write it down, by the time you finish the homework, you'll have these formulas memorized. That's helpful because these are formulas you kind of have to have memorized in order to get correct. So that's helpful. If that doesn't work and you go, I kind of get them, but I still don't have them totally memorized, all you have to do is write it 50 times. And while you're writing it out, say it to yourself. So write it, you would write it once going, x cubed minus y cubed is equal to x minus y times x squared plus xy plus y squared. And you might go, 50 times? That sounds crazy. You could write it 50 times in 5 minutes. So literally in 5 minutes, you can have it memorized, right? People make it like memorizing something is this brutal thing. Not if you systematically force your brain to repeatedly do it and by using different parts of your brain. So that's why you write it. That's one part of your brain. While you say it, that's another part of your brain being used. So if worst case scenario, you don't know these formulas by the time you're done doing the homework, get a piece of paper, write it 50 times. It'll take you less than 5 minutes, and you'll have the whole thing memorized. Okay? Okay, now that we have that established, now I've got my roadmap. How am I going to work my way through the problem? Okay, well, I know I've got some parentheses. So what are the things that are being cubed here? Well, what do I cube to get 8x cubed? Well, 8 is 2 cubed, so it looks like it would be 2x. So I'm going to have 2x. And then, remember, I've got my minus sign because it's same sign, so minus. What do I cube to get 27y cubed? Well, 27 is 3 cubed, so that must be 3y cubed. Okay, so see how I've got the, oh, sorry, it would be 3y, not 3y cubed. Okay, so that's this part once it recompiles. That's this early part done. Now here, this next part I'm about to show you, if students make mistakes, like assuming students know the formula and it looks like they know how to do this kind of problem, but they still make a mistake, this is usually where it happens right here is this x squared term. Because what they do is they go, oh, I'm supposed to square the thing that I had right here, and here's what I see happen all the time. They'll write this as, they'll say, well, 2x squared, right? So they write 2x squared. But that's not right. We're supposed to take whatever the thing that is right here and square it. Well, 2x times 2x is 4x squared, right? 4x squared. So that should be a 4. So don't just square the variable. You have to square the coefficient as well. So that's usually where the mistake occurs when I'm looking at these, when I'm grading them. So we've got now 4x squared because you're taking whatever you cubed to get this and you're squaring it. Okay, 4x squared. Now we go plus. All right, so that's going to be 2x times 3y, which is 6xy. And then plus y squared, well, our y is 3y, so that's going to be plus 9y squared. So you're just plugging things into the formula and figuring it out that way. Okay? And it's the same for the plus. It's just that you have a different formula. But the actual way that you work through the problem is exactly the same. So let's take a look at one. Yeah, let's do a level 1 problem. Actually, let me remember, what does level 2 look like? Oh, this is one that throws people off. Just remember, 1 is a perfect square. 1 is 1 squared. 1 is a perfect cube. It's 1 cubed. So people get thrown off by 1. Don't. It can either be a square or a cube, and then you just include it in the formula just like anything else. So don't let that one throw you. In fact, let me show you the solution here. You'll see they recognize, oh, it's 1 cubed minus q cubed. So they plug it. See, this should look familiar. There's our formula right there. So they just plug it in, and you get 1 minus q times 1 plus q squared. So don't worry about the 1. Don't overthink it. They are really putting a lot of 1s in there. Let's see. I'm going to do one that doesn't have a 1. Anyways, okay, we'll do this one. 125 plus g cubed. And you're sitting there going, 125, is that a perfect cube? I don't even know. Well, you just start going through them because remember I told you there's not that many that get used. So you go, okay, well, I know that 4 cubed is 64. So what would 5 cubed be? Well, 5 times 5 is 25. Times 5 is 125. Oh, that's it. That's the one we're looking for. I'll see students, they are staring up for 10 minutes, 5 to 10 minutes trying to go, oh, I don't know what the cube root of 125 is. Just write some stuff on your paper and figure it out. Just try crunching some numbers. That's much better than like staring at the ceiling, is actually narrowing in on the actual answer. Okay, so just try some. It's not like we're going to give you a problem that ends up being 17 cubed or something like that. They're relatively small numbers for the cubes. So what is it? 125 minus plus g cubed. Okay, then let's take a look at that. 125 plus g cubed. And we've got our formula. So that's a sum of cubes, right? I see that there's cubes involved, and I see that there's a sum. So I'm treating this as a sum of cubes problem. And I'll just kind of sort of be consistent. I'll write it the way that they were writing it in the solutions. So that's really 5 cubed plus g cubed. Okay, so see how I took 125 plus g cubed, and I'm writing it as 5 cubed plus g cubed. Why am I doing that? Because 5 and g are the things we're going to be plugging in down here, right? So, according to our problem then, this will become, all right, well, it's going to be 5 plus g. Okay, now 5 squared, so 25 minus 5g plus g squared. Right, so I'm just using this formula as my roadmap, and I'm plugging things in. I can tell you, when students are trying to think about the formula, substitute into the formula, and simplify at the same time, good chance you're going to make a mistake. Just write it on the paper, okay? Oops, am I kind of going off the side there? Let's see, there we go. Okay, so now you can see that here's our formula. Here's us plugging it in. So let's see, 5 plus g. I have to keep moving this left and right to get these problems to show up. So 5 plus g, and then, oops, and then what, 25 minus 5g plus g squared. And we got it. So remember, see, same thing. They're just saying, okay, here's our formula. What did I cube to get 125? 5. What did I cube to get g cubed? G. And then you just plug those things into this right here is just our formula, but with the individual pieces plugged in. And so you get what we got. Right? So that's really all you're doing. That's the game that you're playing. What's level 2? Level 2. What do you cube to get r to the 9th? It's r cubed. R cubed times r cubed times r cubed is r to the 9th, right? I actually want to do a different one. I don't want to do this one. Let's do next problem. Let's see. Okay, those are fine, but it's not what I was looking for. Anyways, that's the idea behind the sum of cubes and the difference of cubes. That's how that goes. Okay. So it looks like I think there's enough time for me to cover the factoring strategy with the. Oh, there's a question in chat. I didn't even notice. My screen here is bigger than usual, so I didn't notice there was a question in there. So someone's asking, are you going to teach the Math V03 next semester? I'll be honest, I don't know. We end up picking classes usually a couple semesters out, so I can never keep track of what I'm teaching when. I don't know when this. I think the schedule is out. It'll have what I'm teaching and what I'm not teaching. I don't know if I'm teaching a V03 in the fall. I kind of think I'm not, but let's look. Let's take a look. So we go to the schedule. Let's go fall. No, spring. Ventura College math. Search. Let's see who's teaching V03. There's how did we end up in art? That's not. Oh, there's an okay. Weird search. Okay, there's only one advertised V03, and it is taught by John Politowski, who is he's been teaching at Ventura College a long time. I think someone was saying he's been at Ventura College. Anyways, a long time. He's our longest running instructor that's been at the school. So so it looks like I'm not teaching it. Sometimes there's like a secret 103 class, but that's only for students that are in El Camino students. So there's like that one there's the V03 that's reserved for the El Camino students, and then they offer so that one's generally not going to be on the schedule. I don't think that I'm teaching it in the fall. I'm not or the spring. I'm not sure. Let's see what they've got me listed as. Teaching. Oh, right. I'm teaching 2 Math 35s. That's basically intermediate algebra, but for nursing. You do a lot of like nursing stuff in there. What else have we got? Stats and and then I'm actually teaching a course at the Juvenile Correctional Facility next semester. That'll be a new experience for me. So it looks like the answer to that question is no. It appears that at this time I am not teaching Math V03 next semester. We have very good people teaching Math V03, so you'll be in good hands. Whoever's class you end up taking, they'll do a good job with it, I'm sure. I think everyone in our department is pretty good at teaching that class. So yeah, you should be good to go. But it looks like it's not going to be me. I teach that class a ton, but apparently not next semester. That we used to offer a bunch of that class, but it's shrinking down to where they're going to be offering 1 or 0 each semester. They keep the one for El Camino because that's like a special agreement that we offer that so that students can get their high school credit for intermediate algebra. But outside of that, we don't really offer it much at the college anymore. So that's what's going on there. Right. Okay. So 8 minutes. Okay. So I'll give you the brief overview of your factoring strategy, and then I'll try to remember to go over it next time too, just to kind of remind you. But here's the idea. What you want to do is count how many terms are in the polynomial that you're going to factor. And this might seem easier. Like, no, I'm good. Whenever I'm doing the homework, I always use the right form for factoring. But that's because you have an advantage. Basically, you're using the thing that the section is called, right? If you're doing a section called factor by grouping, you're going to use factor by grouping. If you're using a section called trinomials, then you factor trinomials, right? So you kind of already have a clue as to which type you're going to use. But going forward, there's two things that change. One is you don't know what kind to do anymore. You're just going to have a bunch of polynomials jumbled together, and there'll be trinomials in there. There'll be factor by grouping problems in there, greatest common factor problems. There'll be difference of squares, difference of cubes, sum of cubes. And sometimes people who haven't been watching for clues along the way can panic and go, "Oh, I don't know how to decide which form to use," which is fine. But you can get over that. You can learn that, right? So you can learn which one you're supposed to do. So here's kind of your guideline. How many terms are in the polynomial that you're trying to factor? If there is 2 terms in it, then there is a very high likelihood that you're going to use one of those formulas that we learned today. Difference of squares, difference of cubes, sum of cubes. So if someone hands you a polynomial that you have to factor in those two terms, the first thing that should hop up in your mind or pop up in your mind to check is it a difference of squares, a difference of cubes, or a sum of cubes? And most of the time the answer is going to be yes, it's one of those, and then you use the right formula. Okay, so that'll make more sense after you do the homework from today. You'll go, oh, I see. Like when you're doing the homework, watch, and you'll notice all those problems that you do in this section have 2 terms in them, just 2-term polynomials. So when you see a 2-term polynomial, you go, oh, I'm betting that's one of those formula problems, because it probably is. What if you have a trinomial? So it's a polynomial with 3 terms in it. Well, the way that you're going to factor those is generally with your guess and check method, your trinomial factoring method, right? And there's little variations of that. There's the big X method or whatever you want to call it. It just comes down to whatever way you factor trinomials, right? So when you see a trinomial, you go, okay, I might have to guess and check this a little bit, but I'm going to get there. And that's how that problem works, okay? What if there are 4 terms in the polynomial? Then it's factor by grouping. Okay, so see how each time when you identify how many terms are in your polynomial, it immediately narrows down the number of options that you have for factoring that thing. Now, you can do the modified factor by grouping for trinomials. You can use, obviously, the modified factor by grouping for factor by grouping. The only thing you can't use the modified factor by grouping for is the formula problems. Those are the only ones, the sum and difference of cubes. Technically, you can even use it for difference of squares, but they would be kind of silly to do that. So almost all of them can be done in a factor by grouping method, but most students choose not to do it that way. So count the terms. That's going to be your clue as to which method to use. Now, with that said, the problems are also going to escalate in difficulty a little bit in that you are now going to see problems that can be factored, or you may see problems that can be factored multiple times. So you'll factor it and go, okay, yeah, I'm done. And then someone goes, no, wait, one of those factors you have is factorable again. So let me show you what I'm talking about. Here's an example. Here's a simple one. We want to factor x to the 4th minus 1. Okay, we want to factor x to the 4th minus 1, and you go, oh, well, that's a difference of squares. I recognize that. Okay, great. So that's going to factor as x squared plus 1, x squared minus 1. Okay, I've got my factors there. Good. As soon as they pop up on screen. And you go, that's great. I'm ready to put this in the homework and move on. Does anyone see the problem? Excuse me. The problem is that x squared minus 1 is itself a difference of squares. In other words, you can factor this further. So when we say factor now, we mean factor completely, right? Remember when you used to simplify a fraction and you'd like simplify it and then your teacher would go, nope, it's not fully simplified. And you'd go, oh, I can simplify it even more. And you would simplify it till it's fully simplified. Same thing here. You're going to start having problems or questions where it takes more than one factoring to complete the problem, and you got to do that. So what you would do is you just factor it again. Now, x squared plus 1, that's a sum of squares. There's no way to factor that. But this difference of squares we can factor, right? So then what you would do is your next line would be you leave that first factor the same, x squared plus 1, And then how would you factor x squared minus 1? Well, that's going to be x plus 1, x minus 1. Where this x squared minus 1 became x plus 1, x minus 1. So it's just repeated factoring. Make sure you have fully factored everything. Otherwise, you're going to miss a couple problems along the way. Okay, make sure you factor everything completely. So what did we learn today? We learned how to factor with those three formulas. We learned when to recognize what factoring method to use. And then we also learned that we need to look out for repeated factoring. And that completes our understanding of factoring. You can factor now. Next time we meet, I will talk about factoring in order to solve equations, which is just it's like we do everything we just did, and then we take it one step further. So I highly recommend you be very comfortable with factoring by the next time I see you, because if so, you're going to find the next meeting very easy. If you haven't figured out how to factor yet, or you're not comfortable with it, you're going to struggle more. So just try to get that homework done. Try to get caught up on that stuff so you can get it all completed. And let's see, everything should be still, yeah, November 30th. We got plenty of time, but I would recommend start, those of you who haven't completed these yet, try to get that early factoring done. And then when I talk to you on Thursday, that kind of stuff of solving these equations is going to make a lot more sense. The solve by factoring will make a lot more sense to you. Okay, thanks everybody. That's class. If anyone wants to hop into Zoom and talk to me before I shut down the Zoom meeting, you're welcome to do so. Otherwise, I'll see you in a couple days. Thanks, everybody.